Find the region bounded by the curve y equals 4 minus x squared and y equals 2 minus x. If it's solid, find solid. Mr. Up, the parabola down. Yes. And the second one is a line with a y going down. So it wants you to find the volume of that shaded part if you spin it around the x-axis. We okay with that? So what's the first thing we need to do? Find the intersection points. So 4 minus 2 minus x. Solve for x. 0 equals x squared minus x minus 2. 0 equals x2 x equals negative 1. How's that? Are we good with that? Okay, now find the area, into the area, find the volume of revolution. So what we need to do, remember the form I was trying to get you guys to remember yesterday was the integral from the first intersection to the second intersection of the higher function squared radius squared minus the lower function squared dx. Higher minus lower. Positive y values minus less positive y values. So what's the higher function? 4 minus x squared. And the lower function, 2 minus x. So, yuck. Throw this in your graphing calculator. Okay, throw this in your graph. This y1. Yeah. There are these points. Negative 1 and 2. It's the intersection, or the intersection finishes. Or from the left intersection to the right. It's the boundaries of your intersection. From negative, what? Yeah, it is if I could draw. You gotta remember that I didn't draw anything to scale here. I just scribble. So put that gray box in Y1. Got it there? And then go second, trace 7. Negative 1, enter. Positive 2, enter. And what does it say? Why can't you? Well, I don't know. What would happen if you didn't have a calculator? What? So we agree that it's 21.6. We're doing that. Of course it isn't. And then you multiply it by pi and you get the volume, right? Did you round it off? Is it exactly 21.6? Yeah. Oh, wow, that's exciting. So it's 21.6 pi, ultimately 60. Okay, AP students, 3 decimal places, 65.858. 67.858. Okay, I'm deaf. Okay, now I was playing with WinPlot this afternoon because I'm the nerd. And we can get it to do this. The volume of revolution, that's awesome. Then I would use it to check your work too. Yeah. So I was playing with this last night. So first function 4 minus x squared. And then we another one, 2 minus x. Yeah. Now you can get the calculator under TO equation view buttons 1, 2, volume of it. So you got your two functions, y equals 4 minus x. What axis are we rotating around? The lowest. What's the high? Okay, does this what is it? In algebraically, it actually builds rectangles. So our 1,000 little rectangles and rotate more. Computer wasn't volume. Are we doing that's too big? It is. It's just gonna. There it is. 0.7. Huh? Did I type anything wrong? X-axis, y-axis, no, y.
We have 4 minus x squared.
Yeah, no, but that's fine. But it shouldn't, because it's doing it for us. What's that? Well, I can get it to integrate it, no problem. Yeah, but I don't want it to integrate it. I want to integrate it separately, right? That's the problem. Yeah, well, just a sec. Where's integrate? Integrate section rotation. This is what I really wanted to play with. Check this part out. So it's going to involve just so it's for you. So that's what I was playing with. Depending on which. All right. So I don't know. Maybe I did something wrong here, but I thought it was. No, that's wrong. You guys did this. What? Hope you did your calculator properly. Sure you did? Oh, I think I know what my mistake was. I forget it. I don't have 2 in my. Did I? Yeah, whatever. Volumes. Revolution. Comments. These are based on places. They're all formulas. Everything you will do for this and to the rest of what we do for the rest of today is the area of a circle is pi r squared. That's all you really need to know. Try to visualize the slice, then rotate it around a line specified. If it's a disk, pi r squared, or if it's a washer, the area of the big circle minus the area of the little circle. Pi r squared minus pi r squared. When revolving around the x-axis, a washer. Just one circle minus, so this is a washer. A flat donut. Somebody's taken a disc and punched the middle out of it. That's a. Okay. CD make. Yeah. Yeah. big R radius of the outside edge of the CD. Little r is the inside edge of the CD. That's all that is stacking CDs. Good call. Okay. When revolving around the x-axis, to make sure you're taking vertical slices. When revolving around the y-axis, make sure you're taking horizontal slices. Thank you for the CD metaphor. So, what do you need to know? This is what you need. When revolving around the volume equals pi r squared, the area between a and b of f of x squared dx. Or when revolving around the y-axis, look how the formula changes. And then revolving around two functions where you subtract and you don't make a fool out of yourself, it works. I was trying to use wind plot, I'm sorry. And then the last one revolving around on the y-axis. So visualize, visualize, visualize. Okay, on the page.